Hello, sixth grade. Here are your volcano review notes, starting with the first page. The question, are all volcanoes the same? The answer is no. There are different types of volcanoes depending on where they're forming on the Earth. And depending on where they're forming on the Earth, we'll learn that they can erupt different types of materials that can erupt in different ways, and that can create different shapes of the volcanoes. And so the short answer is no. All volcanoes are not the same. So we'll look at those. Pictures of the different volcanoes. In general, volcanoes start where there's an increase of temperature and pressure in the magma underneath the crust of the Earth, and that forces up through a vent the magma until it reaches the surface. So where liquid rock can reach the surface of the Earth, you get a volcano. Once that magma reaches the surface, it's called lava, and around the vent is sort of a crater up there. And we'll talk a little bit more about the parts of a volcano later on, but here's sort of the basic idea of what can start the formation of a volcano. Now, where volcanoes occur, this ties into our understanding of plate tectonics. The first part could be a divergent plate boundaries. If two plates are coming apart, there's going to be magma that wants to come up in between. And sure enough, that happens. And sure enough, they get volcanoes. And a lot of those volcanoes are actually in the ocean at the mid-ocean ridge. But sometimes those volcanoes can go up above the surface of the ocean. And Iceland is an example of that. We'll see a little bit later on. Iceland's an example of volcano forming at a divergent plate boundary. Then, of course, we can have volcanoes forming at a convergent plate boundary, where one plate is subducted under another. When that plate goes underneath, it melts the crust that has gone underneath, and that melted rock is very gaseous and wants to explode and comes up, and you get a very explosive type of volcano at a convergent plate boundary. Mount St. Helens is an example of that. The third type of volcano occurs not necessarily at a plate boundary. Sometimes, like in Hawaii, it occurs in the middle of a plate. Hawaii is in the middle of the Pacific plate. So how does that happen? Well, these are known as hotspots, and that's where the magma underneath the crust, for reasons that are still not entirely understood, bubbles up and goes right through the middle of a plate and creates these hotspots. And Hawaii, again, is a great example of that. We'll look at more of those later on. So again, divergent, two plates coming apart. Here are the convection currents underneath, like two conveyor belts that are moving the plates away from each other. And the magma comes up, and the magma isn't as explosive, isn't as sort of filled with gas as perhaps a convergent plate boundary. It's kind of like a flat soda explosion. It comes up. I'm not saying it's not somewhat of an explosive type of volcano, but it's not as big as, say, as a Mount St. Helens. So here is in Iceland, an island that you can find in the middle of the Atlantic that is forming from a divergent plate boundary. You can think about it, it's really forming new crust. There's new crust being formed by the volcanoes in the middle of these two diverging plate boundaries. Then, of course, you have a convergent plate boundary, two plates coming together. You've seen this picture before when we talked about the types of plate boundaries. One plate is going underneath the other. Japan is a great example of this, where one ocean plate is going underneath another ocean plate. And as that one plate that's being subducted underneath, it brings with it water and other gases, and it becomes like this bubbly, explosive kind of soda. And sure enough, when that bubbly, explosive, high-pressure, high-energy magma makes to the surface, you get a very sort of fizzy soda type of explosion. That's where you can get some of your composite volcanoes. But again, notice though, these volcanoes, the driving factor here are moving convection currents that are bringing plates together, and an aspect of convergent plate boundaries, an effect of it, are big volcanoes. Okay? Then, here's another one. Just another sort of look at convergent plate boundaries. Here's an example too. Not necessarily that the volcanoes happen right near the edge of the ocean. Look how sometimes like Mount St. Helens can be hundreds of miles away from the edge of the plate. See how it goes underneath there. So you might be pretty far from the ocean and still have volcanoes that are forming due to one plate going under another. All right, but the third type is the hot spot. There it is, the hot spot. What's neat about a hot spot is it stays in its place in the mantle, but the plate on top of it is moving along. You saw this in the one Bill Nye video, but this idea that the hot spot can form a volcano, it erupts, molten material comes up, perhaps forms an island, you get a new island right there, but then the plate moves over the hot spot. So if this was island A, it moves over this direction, and up comes island B. Then it keeps moving, so now A and B are over there, up comes volcano C. And it continues and continues. So you can get this very long line of islands forming from one hot spot, here it is in Hawaii, forming a line of volcanoes. And when geologist goes and dates the ages of the rocks, sure enough, the youngest rocks, the most recently formed rocks, are the ones closest to the hotspot. And as you go farther away from the hotspot, the age of the volcanic rocks, the extrusive igneous rocks, gets older and older and older. And this continues at the islands of Hawaii. Not just the islands of Hawaii. Look, here's Hawaii right there. These actually, the islands, and now some of the seamounts that are underneath the ocean from this one hotspot that's there has been forming for millions and millions of years. Look how long this goes. And you get the idea of this plate has been moving over this hotspot for a long, long time. Kind of neat to see. Now, parts of the volcano. Pretty straightforward. You have a magma chamber. This kind of like, I call it like the belly of a volcano, up which comes the magma once it gets hot enough and energized enough with gas and temperature. It comes up through pipes, main pipe in there, and can erupt through a vent, whether it's the main vent at the top or perhaps a side vent. When it reaches the surface, that's a vent. At the very top, you have a crater, or sometimes on a very large volcano, we call them a caldera, but it's kind of the main top of the volcano, and out of it can come ash and cinders, otherwise known as tephra, or it can come out lava. As the magma reaches the surface, if it oozes down the side, that's lava. So the ash and cinders and the lava can form extrusive igneous rocks. This is here because if you think about it, if a magma chamber ever cools and slowly becomes intrusive igneous rock, this is how you can get granite. A lot of times granites are the ancient bellies of old volcanoes, which is kind of neat to think about. So know those parts. Now, the three types of volcanoes, put all this together. The first is a shield volcano. Shield volcanoes ooze lava. They're not explosive. The lava oozes out, comes down the side. Cinder cones, they are explosive. They erupt ash and cinders, but they're not that big. They grow into a sort of a cinder shape. Again, ash and cinders, sometimes known as tephra. And the last kind, biggest kind, the composite, or sometimes known as the strata volcano. Sometimes they explode, sometimes they ooze. So they create this sort of mixture of tephra and lava. That's sort of the different layers, call it the strata, or a composite of kind of cinder and shield together. And these are the big ones. Back to examples of a shield. So here's geologist Jane there with a shield volcano. It oozes out the side. In fact, right now it's oozing in Hawaii, slowly going over some houses, unfortunately. But it's not dangerous because it kind of oozes so slowly. You can kind of plan where it's heading or just be okay with it because it's not that dangerous. It's not that explosive. Geologist Jane is okay. Then with a cinder cone, again, okay, it is more explosive, right? But it's sort of small. It's not nearly as big, only about 2 kilometers max. And so though ash and cinder are coming out the top, you can be careful. Perhaps you wear a helmet. You can get just close enough, but be okay because you kind of know where the ash and cinders are coming and you're all set. You can also have volcanic bombs where a little bit of the lava, a little gloop of lava comes flying out and then hardens in the air and solidifies and falls down. That's kind of cool. But then you have the composite volcano. Mixtures of tephra and lava and a third kind of material that can come out known as a pyroclastic flow, which is sometimes almost called like the superheated cloud of cinders and gas, poisonous gas, and it's dense. It's denser than air, so it rolls quickly down the side of the big volcano, and these are quite dangerous. This is what knocked out the city of Pompeii in 79 AD from Mount Vesuvius. These are dangerous. These are very dangerous types of volcanoes, and sure enough, there's geologist Jane. She needs to get out of there. This can be a very dangerous type of volcano. Again, same 3 types: cinder cones, made of cinders; shield, made of lava flows; composite, made of both. Another way to look at it, here's another just sort of together, of the 3 different types. What's their shape? How do they explode? What comes out of it? And I think that's basically it. We have a couple more pictures of examples of volcanoes. This picture, by the way, here is the island in Hawaii. You can see the huge shield. This is actually a little cinder cone on top of a shield cone. Sometimes cinder cones can be literally on top of much bigger volcanoes. Mount St. Helens, a classic composite. Wizard Island is a good example of a cinder cone. See, it's not that big. You could probably take, kayak around this in probably an hour. It's not very big. It's actually within a huge caldera, but this is a small cinder cone within a bigger caldera. But that's a good example of cinder cone. Fuji, another composite volcano. All right, there's the homework. There's the rest of the review. I think we're all set there. That's it. Check with me if you have questions. Take care. Bye.